sponsor, CBC contributor. He serves on the boards of Illumina and Pfizer. It's weird. I mean, there is disparity on the way the immune system responds to different viruses. Does it make sense to you, though, that the antibodies in this case would not last as long? What determines that in terms of what you know about science and medicine, Doctor?
Well, the circulating antibodies may not last as long in certain patients. And first of all, it's highly variable, and it may be that the asymptomatic patients in this study were more likely to be younger patients as well. And what we've seen in past studies is that younger patients seem to mount a less robust immune response in terms of developing an antibody response. But that doesn't mean that they're not going to have immunity. There's different kinds of immunity. As you know, there's the cell-based immunity, T cells, there's memory B cells. And so there's a lot of different cells that probably have adapted to develop some form of immunity against the virus besides just the circulating antibodies. And the other thing about this study, notwithstanding the fact there was only 37 patients, so hard to draw conclusions from it, is that there were two types of antibodies they were looking at, IgG and then neutralizing antibodies. And it was the IgG that they didn't have a lot of, but they had a lot of the other kinds of antibodies. And so it's hard to draw a conclusion from this study that you wouldn't have immunity. It just said that you didn't have a lot of circulating antibodies on the same level as people who are symptomatic, which might make sense because it seems to be that people who are asymptomatic don't mount as aggressive an immune response.
Like so many of these studies, once again, it comes out, we see the headline. I don't know whether that's our fault, the media's fault, or whether it's that they're not clear enough on what they're saying. So this was measuring circulating antibodies, which may or may not correlate with the immune system. What do memory B cells do?
Right.
They don't work like T cells. What do they remember what they saw and make antibodies if they need them again? Is that what they do?
Exactly. That's exactly what they do. You can have memory cells in your lymph nodes, and then you don't necessarily have circulating antibodies. But you have cells that can adapt very quickly. There was another study in Nature in the same issue showing that asymptomatic people seem to shed virus for a long period of time, which also is concerning. Wasn't clear whether or not the virus they're shedding was actually alive. They didn't try to culture it, so it's not clear that they're contagious for a long period of time. But you can assume that. And so what it might suggest is that asymptomatic people, part of why they may be asymptomatic is they're not developing that robust immune response that's part of the symptoms that you develop against COVID. And so they retain the virus for a long period of time, they shed it for a long period of time, and they don't develop as robust of an immune response to it because they just kind of live with it in harmony rather than having a revved up immune response to it. And so that's what these two studies could suggest. Other studies have suggested a similar kind of activity.
Nature medicine, is that different than nature, Doctor? They change it, or is it?
It is.
It is different, but is it part of the overall?
It's part of the nature family, but it's not nature. Nature has a lot of different journals.
Nature